Welcome to Module 203B on temperature sensing and control devices. Each different type of temperature sensing device has a different job within our heating and cooling cycle, and Objective 2 goes into what those applications are. The high limit control is meant to prevent a dangerous situation from developing, such as the plenum overheating due to a blocked duct or faulty blower. Its job is to shut off the burner. Typically, we use either disc type or spiral type, and it is placed in the furnace at the top of the heat exchanger. If you have a downdraft furnace, you have two high limit controls, one at the top of the furnace and also one inside the plenum. If you use a disc type high limit, they are not adjustable, so they need to be preset anywhere between 80 degrees Celsius and 120 degrees Celsius. For our spiral type, like you see on the screen, that should also be set within this range. The newer models of furnaces use thermistors and electronic circuit boards to regulate the high limit control. These are much more reliable and they're programmed using dip switches. The switch orientation itself will determine what the temperature maximums are going to be. And the more dip switches that we have, the more available settings we have as well. The next temperature sensing device we have is called fan control, and it automatically starts and stops the fan for optimum heat circulation. The fan control allows the plenum to heat up before starting the fan to minimize any cold air circulation. And it also keeps running until the plenum has cooled to prevent any heat waste. It uses a normally open bimetal strip located inside the plenum in order to control the fan. Most fan controls also contain a manual override switch, which can be installed in parallel to the fan control to keep the fan running longer, which is good for air circulation and heat balancing. When setting up the fan control, we need to consider economy, comfort, and proper cycling. We set up two different set points. The high set point turns the fan on and should be set just inside the upper comfort level. The low set point turns the fan off and should also be set just inside the lower comfort level. If the fan set points are set either too high or too low, what will occur is either room that's going to get too warm or too cold. We also need to consider how closely our two set points are to each other. If they're set too closely, it will create what's called unwanted cycling. As soon as my fan starts, we notice that there's a significant drop in temperature inside the plenum, since it is mixing cooler air with the heated air. If that temperature drops below the off point, it will turn the fan off, which will allow the duct to heat up again to the point of the fan on, which will drop below the fan off point. This cycling can cause premature wearing of the motor as well as multiple other problems within your furnace. In the case of economy, we want to make sure that the fan off is not set too high because this can waste heat, which means the heat can escape through the chimney instead of being used inside the house. Typically for my fan controls, I want the fan to turn on anywhere between 49 and 60 degrees Celsius, and I want my fan to turn off anywhere between 32 and 38 degrees Celsius. The difference I should see between these two settings should be between 17 and 22 degrees. If they are too close, it's going to create cycling. Keep in mind, a lot of these settings are going to be site specific, so we can adjust them at the site itself. In a lot of older units, we see a combination unit that contains both the fan control and the high limit control. If this is the case, we have to make sure that the high limit adjustment is higher than the fan on adjustment. We want to make sure that the high limit will activate if the plenum gets too hot, but we don't want it shutting off the gas too early neither. And any unit that uses a combination control that will have both the fan control and the high limit in it, I need to be aware of the voltages for each of these systems. Canadian Electrical Code says I cannot mix my 120 volt circuit with my 24 volt circuit within the same device. Since my fan control is a 120 volt power circuit, and my high limit operates my ignition circuit, which is lower voltage, I cannot have both those voltages in the same control. If I do have one control for both of those units, I'm going to use my high limit to control the transformer that powers my valve. That way, all the power that is inside that combination unit is 120 volts, and I'm not mixing any voltages. You have now reached the end of this objective. Review your module, complete the knowledge check, and then continue on to the next video.